Okay, good afternoon, folks. Can you hear me and see the image of the lecture? Can you guys hear me well or no? Hello? Oh, okay, thanks. Thank you. Great, appreciate that. Okay, this is lecture 16, and we have 3 more lectures left after this lecture. And I have I've put Excel number 7, I think, on online on Canvas, and I'm contemplating on giving you guys optional Excel. Optional means that it's gonna replace your lowest score. If you don't do it, you won't lose anything. It's just a win-win situation for you guys. And if you do it better than your lowest score, one of your lowest score Excel assignments, it will replace that. And if you don't do it, you won't lose it. Another way of saying it, I will drop 2 lowest score instead of 1 low score. So, so you will benefit out of it. If you do well, if you get a better grade, that means it's going to help you. If you don't, you won't lose anything. So anyhow, I'm considering on that, and if I have something like that, I will put it on Canvas soon because I want to give you enough time to finish it by not this coming Friday, but the following Friday. Then you can get ready for your exam. All right. If you don't have any question, let's just continue on chapter 22. And last time we went through this part of this chapter. If you recall that we are dealing with, in general, it is basically we're talking about the population proportion. Previously, we talked about population mean, 1 sample, 2 sample population mean, and this is one the population parameter proportion that we are using. We are looking at it. Basically, we are looking at the proportion of the population, 1 sample. And chapter 23 is going to be 2 samples. And we went through this, if you recall that, this is like a sample statistic for mean, this is for population, and we learned here that proportion is defined, proportion with a caret or hat, it's for the sample, without caret or hat, it's for the population. And proportion means that, if you recall that, here's the formula for proportion, the number of successes in a sample divided by total number of samples. It's not an extra credit. If you do it, it becomes an extra credit. If you don't do it, you won't lose anything. Excel, optional Excel is something that you benefit. You will not lose anything. It will to your benefit. With it, if you don't do it, nothing is going to happen. Your grade is going to be the same as before. If you do it and you get a better grade than one of your lowest score, it's going to replace that lowest score with a better grade. So it's a win-win situation for you guys. Because I felt bad because I turned down a lot of students in the past for, I don't know, wrong. They put their names wrong. They had a $ and by mistake they submitted a wrong Excel assignment. I thought that if I give you an extra uh, Excel, optional Excel, that will help you. That will alleviate some of the inconveniences. Anyhow, well, I will work on it. Probably, I don't know. I'm a little bit busy. I'm hoping maybe this week I can put it online. Hopefully Thursday, maybe, or Wednesday, Thursday. I'm gonna do my best because I want to put these out and then work on review questions, final review questions. I already got the room for you guys. And Christoph is going to be your instructor on Thursday from 4 to 6. That means not this coming Thursday, but the following Thursday. And just a few days before your exam. Your exam is going to be on Monday. And I will send you guys, I will put something on Canvas, and you guys get an email on that too. But just one more thing that I got to mention, now you brought it up, is that those of you who have conflict, your final exam is in conflict with my final exam, you need to talk to the instructor who has more students. The instructor has more students, he or she is responsible for giving you a makeup exam. Like for instance, some of you guys have Econ 202, I know that. There's a conflict between that, but Econ 202 is way bigger than my class. So your instructor in Econ 202 is responsible for rearranging your final exam. Just a note, but if you want to do it, you got to do it quickly because we are getting there. So we want to make sure that you're covered. Okay. All right. So let's continue. So this is, if you don't have any other question, let's just go with this. And also your Excel for tonight, it's going to be new Excel. You're going to deal with the +4 that I'm covering today, +4 calculation confidence interval. We'll go through this today. And it's similar to what you have. It's just an extra formula, basically, extra parameters and things like that. Okay, and also, if I get a chance at the end of this class, I might just stop a little bit early because I want to show you something on Canvas. Your Excel assignment this time has autism, non-autism, male and female, and I want to show you how to sort them. Like if you want to sort them that female have autism versus not having autism, and that versus men and women, with men and with the autism and without autism, you have lots of cases. So there are like close to 1,000 data points. You can't just sit there and look one at a time so you see, okay, which one has autism, which one is male. So I want to show you how to sort those. So it's easier to do it. I will do that at the end of, maybe I should do it now. What do you guys think? Do you want to see it now or do you want to see it at the end of the class? Hello? Yes, I'll wait to the end of the class then. Okay, let's talk about this now. So we have problem, this is exercise 2. The Gallup poll found that 74% of the 2027 smokers they contacted answered yes to the question, all things considered, would you like to give up smoking or not? Find a 98% large, just pay attention here, large sample confidence interval for the proportion of US smokers who would like to give up smoking, all things considered. So here in the size of the sample, you can see this is the 2027 smokers. They answered that's the sample. And the success rate was 74% of these 2027 answered the question. So if the success rate is 74%, so the failure rate would be 1 minus that, and that would be 1 minus 0.74, and that would be 0.26 or 26%. That is the failure rate. So we got those out. Now, let's find a number of successes. Again, we know that we use this formula, the first page formula. So number of successes is equal to p hat times n. You just multiply this diagonally. 1 times that is equal to n times p hat. So therefore, number of successes would be n times p hat. And n is the size of the sample, 2027. And 74% was the success rate. So you multiply that, the answer is approximately 1500, and 1500 is way greater than 15. Remember, this is the limit for the large sample confidence interval. We're trying to get there. So the other one is the failure rate should be greater than 15. Otherwise, we can't do that. So let's see. Number of failures is equal to n times 1 minus p hat. That is a failure. So that would be 2027 times, and 1 minus p hat, we got it from here, and that is 0.26. And if you multiply that, you get approximately, what do I have here? Do I have it with me? Yes, 527. And that's greater than 50. And the third case is we want to know that the population is greater than 10 times the sample size. Is it greater than that? So that means we want to know population is greater than 10 times n. And here we have 10. N is 2027. That means 20,207. Of course, population of smokers in the United States is way, way greater than 20,207. So that is okay too. So since we okayed all these three cases, now we're going to look for a large sample confidence interval. So we also need to know 98%. Z star would be equal to, for 98%, let's just say 98% gives you Z star. What do we have here? Let's see. 98% is there. You come all the way down here, it's 2.326. 2.326. So that is Z star 2.326. Now we have Z, this is Z star. We have Z star. We have all these values we got to find. We have to look for the confidence interval formula. And if you recall that, we had this before, confidence interval. This is the formula we are going to use. It's on page 2. Okay? So therefore, confidence interval is equal to, it's p hat plus Z star plus or minus Z star, square root of p hat 1 minus p hat divided by n. Okay, so we calculated p hat is here, is we have it, right? It's 74%. So that would be, we got to put these numbers there, 0.74 plus or minus. Z star is 2.326. Square root of p hat again is 0.74. 1 minus p hat is 0.26. N is 2,227. Just put the numbers there and plug it in your calculator and you come up with this answer. 0.7173, and this is 0.7627. That would be the proportion. Okay, it can happen between with the 98% confidence interval can be between those two numbers. All right. So let's move on to the next one. And the next one is here for a significance test. Remember, this is again inference statistics. We have confidence interval and what? Significance test or tests of significance. So we already did the confidence interval example, and this is going to be a significance test for the population proportion P. So here again, we are going to go back. Do you see that it's repeating? It's the concept is the same. Everything is the same except the formulas are changing. If you understand, if you know, the first time when we talked about null hypothesis, confidence interval, if you understand that and you know how to do those things, this is going to be exactly the same thing, only with different formulas. That's it. Here the formulas are different, a little bit different. Here what we have, again, null hypothesis, you're assuming that the population should be equal to population P0. Again, remember, null hypothesis and alternative hypothesis, only values you can use here, they must be population values, not sample values. You do not use any sample values in defining the null hypothesis or alternative hypothesis. Always it's a population parameters, okay? So therefore, P is the population parameter and P0 is something that it's the norm, it's no difference, kind of the same idea, the same definition, but we are using for population. In the past, we used for mu, now we are using for population, for proportion, I'm sorry, for proportion. So proportion against 1, so again, H sub A could be greater than P0, less than P0, or not equal to P0. I just want to draw something here to bring it to your attention. Previously, we had this for mu. We said mu H0 is equal to mu 0. HA had 3 cases, either mu greater than mu 0, mu less than mu 0, mu not equal to mu 0. And we had Z for this to be x bar minus mu 0 divided by sigma over square root of n. This is from the previous lectures. Now we are using the same thing. Here, H0 is P equal to P0. See that, the similarity? This is a proportion, that was a mean. And HA is, we can have P greater than P0, P less than P0, P not equal to P0. And again, this is the Z for this one. The same Z you can compare with this Z. Here you have the difference between sample mean and population mean. So here you have the sample proportion and population proportion. You see that because we are dealing with the proportion. Down here, you had a sigma over square root of n. Also, we had this one in terms of S's, but here, since we are talking about the failure and successes, so there to be success times failure. It becomes like a sigma squared, and we can take it out. You can see the similarity here, and that's n. The only difference is we are using it for population. For proportion, I'm sorry. I keep saying population, for proportion. Everything is for population here. Okay. Let's look at the note here. This is an important part. When you want to use this one, you want to follow these numbers when you're doing the test significance. Only perform this test when NP0 and n times n minus number of failures and time and number of successes, number of failures, minimally they have to be 10 or greater than 10. When the number of successes and failures are both at least 10, at least 10. If it's below 10, then you're going to see that we are going to use another method, which is called +4 method. We'll do that. But if it's greater than this, or the problem says that use the large sample confidence interval or large sample calculation, then use the large sample calculation. Okay? All right. Let's do this. This is example 3. It says, bored one Saturday, you flip a coin 3,247 times and get heads 1,678 times. Is there significance? Is there significant evidence to imply that the coin is biased? We want to know that. Okay, so if I want to write the null hypothesis versus alternative hypothesis, how do I do it? The norm is when you toss a coin, you should get 50-50%, right? So basically, P0 is going to be 0.5 or 50%. So when you write the null hypothesis would be your P is equal to P0. In this case, would be basically P is equal to 0.5. The alternative hypothesis is, which one is that? It says, is there a significant evidence to imply that the coin is biased? Bias could be, it doesn't say that whether it's a heavier or lighter. So it could be either, you know, so it doesn't give me any information, but it says it's different. Bias means it's different. So therefore, I can say P is not equal to P0 or P is not equal to 0.5. That is the alternative hypothesis. Okay. Now we wrote those. Now we gotta figure out what the P hat is. We know what P0 is, and remember, in order to calculate P value, we need to know Z. Remember, Z from last page is equal to, you have P hat minus P, this is the population proportion, and divided by P0, 1 minus P0 divided by N. So we do have P0 here. These are P0. Okay, P0, P0, we have the size. What is the size? N is equal to, the size is, based on what we have here, this is how many times? Total of 3,247 times. Flip the coin. We have this. The only thing that we don't have is P hat. So we got to figure that out. So P hat, we know that NP hat is equal to number of successes which is equal to 1,678, which is greater than equal to 10. And the same thing, we've got to prove one number of failure. Number of failures, and that is equal to, you have to subtract from 3247 minus 1678, and if you do that, you get 1569, which is greater than or equal to 10. So that is correct, that's correct. So we can use now the p-value of to the z, get the z and use the z formula and find the p-value. But before we do that, we need to know what p hat is. The definition of p hat is equal to number of successes, first pages, you can see that. Number of successes divided by n, and number of successes is, we have 1,600. This is a 1,678 divided by the total number. Total number is 3,247. And if you do this division, you get a number which is a little bit higher than 0.5. That would be p hat. So I guess the rest is obvious, right? Z is equal to p hat is 0.156. P dot is P0, P dot is 0.5, and square root of P dot is 0.5, and the other one 1 minus 0.5, N is 3,247. If you do this calculation, you get a number 1.9146. Okay, so this is the Z value. So if you recall that we are doing this for what? P not equal to P dot. So therefore, if you want to calculate this, you have to calculate P value would be what? 2 times, because it's not equal. And this is greater than that, so we're going to write 1 minus. I'm going to C less than 1.9146. And this would be equal to 2 times 1 minus 1.9. Here's 1.9. What is it? 1.91. 1.91. That would be this value, 0.9719. 0.9719. So if you multiply that, subtract it and multiply it, p value is equal to 2 times 0.0281. That is equal to 0.0562. So 0.0562 greater than 0.05, therefore failed to reject the null hypothesis. Therefore, we accept the null hypothesis and we say the coin is not biased. Okay? Very quiet out there. Are you guys still here? Is the system working? One person's okay. Good, thank you. So I just want to make sure. Sometimes it's very quiet, and I think that maybe we got disconnected or something happened. All right. So this is the part that I was telling you that +4 is more reliable when you do the experiments, and it is. I don't know the origin of +4, but apparently when you do it, you get a better answer. That's what they say. But in general, we use this one when. Now let's go through this. Let's go through the definition. The large sample confidence interval is fairly unreliable unless the sample size is very large. Like in this case, you saw the sample size was large. 3,247. Or with the smokers, you saw that it was 2,000 something. The +4 confidence interval for P can be used when n is less than or greater than 10. It is obtained by adding 2 imaginary successes, 2 imaginary failures to the sample. So you have, instead of putting now, you know, we had this, we use this, let me show you, compare this. Here, what is this? Here, we use P plus the P hat. Instead of using P hat, we are going to use P tilde this time. And the P tilde is going to be number of successes plus 2 divided by the sample size plus 4. All in all, we are adding 4 data points, 4 units to the sample size. Out of those 4, 2 are successes and 2 are failures. So therefore, when you're defining new P, that would be P tilde, it would be number of successes plus 2 and sample size plus 4. That is the only difference that you gotta remember when you do this. Okay? And the same thing goes with the P hat, P tilde. That would be the failure. And that would be number of failures plus 2 divided by n plus 4, sample size. What is it? Yeah, it should be less. Does it say what? Oh, something wrong. This should be, thank you. If it's smaller than 10. If it's greater than 10, we can use that one, but that's not reliable. I mean, you're going to see that if it's a large sample and you have large sample and it meets the criteria that it should be greater than equal to 10, large sample, we use the large sample testing. We use that one. But if the sample size is small, if n is less than 10, then you have to use +4. Good. Thank you, Emily. Okay, let's just do, this is the number of failures. This is CI, you know, confidence interval. We use that. And that's P hat. Remember, this is used for +4. +4. Remember, this is extra successes. This is extra failures. And this is extra data points. The formula is the same as the other one, only thing that you add to the successes or 2 to the failures to add 4 to the total number. Okay? All right, let's do an example. An example is here what we have. An SRS of an elementary school latchkey program determines that 8 out of the 15 families surveyed put at least one of their children in after-school care. Okay. We would like to find a confidence interval for the proportion of all families who put one or more elementary school-aged children into after-school care. Explain why a large sample interval is not valid in this thing. Well, let's just compare them and compare the criteria for each case and conclude why not. Okay, for large sample criteria, so for this one, we have number of successes has to be greater than or equal to 15. Number of failures has to be greater than 15. N should be large. N must be large. Okay, this is for large sample criteria. On the other hand, let's do it for +4 criteria. So in this case, what do we have? We have number of successes is what? Number of successes, it's 8, right? Which is less than 10. This is because it says, if you read this here, it says 8 out of 14 families. So that would be number of successes, 8. Number of failures, that would be 14 minus 8. That would be 6, which is less than 10. And the sample size, 14, is really small. Is small. So therefore, we cannot use large sample method. Okay? And from here, the information, again, this becomes, I'm going to write it down, NP hat. That would be number of successes. Is 8. N times 1 minus P hat. That would be number of failures. That would be 6. And N is 14. Large enough, it should be greater than 40. If you recall, it depends on what you're doing in general, but it should be like, for instance, large we did here. In the case of like, if you recall that we had, what was it, lightning, and we only had like 4 samples, 5 samples. Rarely can happen. But like with the coin, you saw that we had, what was it, 3,000 times we flipped the coin, or 3,500 times. Or with the smokers, we got like 2,000 some people responded, and we had 3,000 samples. Those are large. We call them large. And small, just based on the successes and failures, you can see that if one of this is small, you're going to expect that the other one is going to be similar to that. So therefore, the overall, I don't think it's going to be greater than 20 or 25. So that's small. That's very small. Because that's the condition for +4 that we are going to use. Using the +4 method, construct a 90% confidence interval for the true proportion of latchkey families. All right. So in order to do that, first we want to know 90%. 90% is going to give us, is 90%, 90%, 90%, 1.645, right? Here's still, some of you guys still have problems with this. 90% on the top, come down, you see 1.645, that's Z star. Z star 1.645, okay? So Z star is equal to 1.645. Okay, we have that. Now we are going to use, let's just see, we are going to use P tilde. Remember that? And P tilde is equal to P hat plus 2, and we have number of successes divided by n plus 4. And the failure would be 1 minus P hat plus 2 divided by n plus 4. Okay, number of successes. So let's just do this. So P tilde would be, what is that? What do we have? P hat? P hat is 8, right? You add 2. Total number is 14. You add 4. So P tilde is 10 over 22. And that would be 10 over 18. How did I come up with 22? I have no idea. 10 over 18. 10 over 18 is approximately is equal to 0.556. And the failure you can subtract from that, but we can start using the formula, and the formula was here. This is the formula. That is the formula. We're using this formula. So I'm going to use it here. Confidence interval is equal to P tilde is 0.556 plus or minus, we're using this formula. .556 plus or minus Z star we calculated was 1.645 square root of 0.556, 1 minus 0.556 divided by n was 14 plus, this is 14 plus 4, that's 18. Okay. So we have to just do the calculation for this. And if we do the calculation, do I have the numbers here? No, I don't. I have CI is equal to, I have the overall number, 0.329. And this is 0.7483. And this is, remember, this is plus for method. I think when you do Excel, this Excel, it's going to be available to you at 6 today. I think this Excel has one problem using +4. Again, +4 doesn't have any, you saw that. I didn't come up with any special formula. You can manipulate these formulas on Excel too. Like adding a number, dividing it by another number, that becomes p hat. Just make sure that when you want to write p, write it p slash hat. You don't have this p hat in Excel. Write it like this so it shows that it's a p hat. Okay. We're done with this. Let's move on to the next problem. Here what we have. Another thing that, how do we pick the size of the sample? Someone asked a question that what we want to do. Here what we have, how to choose a sample size to get a desired margin of error in confidence interval. You've done this problem before, but for this one, for the proportion, let's see what we are going to do. It's a similar thing. You're going to make the entire margin of error less than what is it? It's whatever it's given to you, and then you're going to calculate. You're going to put the values there and calculate n, and you're going to round it up, and that would be the size of sample. Okay, one important thing that we should know here is because the margin of error depends on p hat, that is proportion, sample proportion, we need to guess p hat. We will denote this guess by p star. These are the problems are going to give you a little bit of hard time to remember in the final exam. So you need to work on these things and also put some of these definitions or some of these symbols in your index card. So anyhow, now we are defining p star to be the guess value for p hat. If you would expect p hat to lie between 0.3 and 0.7, use p star to be 0.5. This is most conservative guesses. This 0.5 gives you the best result, and that's why we are taking 0.5. Otherwise, you use a guess from pilot study or a p hat from past experience with similar studies. So that is the case. Knowing that, let's just do this problem. Example 5. Suppose that U of O wants to build a parking garage on campus, and a committee is formed to gather information about whether U of O students are for or against the parking garage. How large of a sample does the committee need in order to estimate the true proportion with 95% confidence using the large sample method with a margin of error no greater than 0.5? All right. So we are going to use, therefore, margin of error. It's going to be, remember, Z star. We had this one before, right? Instead of writing p hat, since we are going to guess what p is, we're going to put p star. When it comes to the size, that's what we do. 1 minus p star divided by n. The most conservative value, p star, we said is 0.5. Most conservative. Most conservative value. And if you look at the 95% confidence interval, that gives you Z star to be 1.96. I think by now you guys know how to do this one, but if you want it, just say yes. I will show it to you again how to do it. So we have Z star to be 1.96. But we want this margin of error to be less than 0.05. So margin of error, we want to be less than 0.05. Therefore, the formula z star square root of p star 1 minus p star divided by n, this needs to be less than or equal to 0.05. So let's put the values there. You have 1.96 for z star. You have 0.5 for p star. 1 minus 0.5, that's another 0.5, divided by n, less than or equal to 0.05. There are many ways of doing this. I can show you both ways, but I will divide 1.96, 1.96. This cancels with that. Then I will square it. The next thing is I'm going to square it. Square this. I have to square this side too. Right? This is green. Square that, square that. If I square that, square root will go away. So I have multiply those two. This would be 0.25 divided by n. Square root will go away with 2 to cancel each other. 0.5 times 0.5 is 0.25 divided by n. This should be less than or equal to. Then you got to divide this number and see what you get. I think this number, if you divide it something small, I don't know what the number is. But, anyone has a calculator to divide this number? Square it? Yes, no? Use my cell phone again. Okay, let me just, the reason I want to do that, because if I don't do it, it's going to get a little bit messy. I usually don't do it. I just, it will get messy for you guys. Oh, thank you. You got it? Thank you so much. Okay, it is 6.5077 times 10 to the minus 4. That's good. Now, if you want to find n, there are two ways of doing it. Either you put a 1 here, you multiply these diagonally and equate them. Not equate them, but less than that. So 1 times that, that would be 0.25, less than or equal to n times that. N times 6.5077 times 10 to the minus 4. And then divide everything by 6.577 times 10 to the minus 4. This cancels with that, and then you get this number. This number should be, I had this number to be 384.6 n. So this has to be, n should be, this is smaller than the n, so n has to be greater than that. Remember, since we are talking about individuals, and whole should be a whole number, and whole number for this would be, n has to be 385. If you put n equal to 385 and calculate all these things, provided that the most conservative value for p hat, which is a p star, it's going to be 0.5 with a confidence interval of 95%, you get this kind of error with the n of 385. Okay? All right. Here, there's another method. I do this because some students likes to see how to do it. Here, when you got up to here, 0.25 n is less than or equal to 6.5 times 10 to the minus 4. So another way of doing this is this answer. Okay. Another way of doing this, you can flip this. When you flip it, n over 0.25, and always greater than or equal to becomes, it's less than or equal to becomes greater than or equal. Because when you flip something, the sign is going to change too. That would be 6.577 times 10 to the minus 4. And then you multiply everything by 0.25, multiply by 2.25, multiply by 0.25. This cancels with that, and you have n greater than or equal to 0.25 divided by 6.577 times 10 to the minus 14. That would be 38416. You say n has to be 38. Okay. All right. We are done with this chapter, chapter 22. We're going to move on to the last chapter. That would be chapter 23. And again, that chapter 23, it's going to be similar. It's going to be two proportion. It's the same thing we did with the two means. We dealt with the mean t distribution, then we did with two sample, two means, and then we dealt again t distribution. Here it's the same thing. So we are dealing with the one. We finished dealing with one proportion, population proportion. Now we are going to deal with two population proportion. Again, the idea is the same. The only difference you can see their formulas. You don't get scared by formulas. You know what they are. You're okay. You can. I mean, you already know the subject because we've gone through this 4 or 5 times. Concept is the same. Okay. This is chapter 23 and comparing two proportions. And again, we are doing proportions. This is going to be part of, we are looking at population, basically. Proportions, we want to know what's going on, basically. We are gonna have two groups, again, two different populations, two samples, two sample sizes, and all those things. The way we did with the means, two means is a similar thing, but instead of using means, we are going to use population. Previously, in the two means, we use like x bar 1, x bar 2, mu 1 and mu 2, and the sample size was the same. I mean, it was different, n1 and 2. Here, we switched it to, instead of having x bar, now we are having p1 hat, p2 hat. Instead of having mu's here, we are having p1 and p2. Sample sizes are there too. Okay. Let's see. And this is the difference in sample proportion is approximately normal. It's talking about this formula with the mean equal to the true difference in population proportions. So this is, let's just define what these are. The first term over here, it is sample proportion. difference in sample proportions, this part. This is this little wiggly stuff with the dot, that's approximation, approximately. That n goes to the normal here, okay? And with the mean equal to the true difference in population proportion, And this entire thing is, this would be what we call it, standard deviation, right? Those are these are the sample sizes. I want to draw something here with the means and compare those things, then it becomes more tangible. Remember, we had this group. We had group 1, group 2. Then we had here, if you recall, that this was sample mean. And we had X bar 1, X bar 2. Then we have sample size, N1, N2. Then we had population mean. And this was mu1 and mu2. And here, the formula we use for this one, if you recall that, this was x1 bar minus x2 bar. We said it's approximately equal to, we had here n mu1 minus mu2, comma, and we had S1 squared over N1 plus S2 squared over N2. This goes for this one. And this is two means versus 2 populations, we have 2 means. Are we still going to go over Excel before the end of the session? Maybe I should do that. Okay, let's stop here. That's fine. Probably we'll be done with this either Wednesday or beginning of early lecture on Monday. Just let me remind you that if I'm gonna find some questions. I had some from last term, so I'm gonna look for them if I can find them. Otherwise, I will pick some questions from the book. It's gonna be from the textbook or test bank or something from the same authors. So I will pick some. I will post them on Canvas for next week. I know that it's not gonna be this week, but hopefully on weekend I have more time to find these questions and post them on there. So we will go through those problems and questions next week. Okay, let's go to Canvas since you guys want to see it. This problem is let's see. I gotta say. All right. So it's gotta be a little bit patient. I'm going through this. Open. One. Okay. Do you guys see this? Do you see the Excel sheet, people? Yes? You see it? Oh, good, 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 good. What happened to my Excel sheet? Okay, let's go and look at this. I had this here. Let's make this one a little bit larger cells. It's too large. Okay. Here you're going to see that this is the data that you have. So you have autism spectrum disorder, yes or no, and then you have the sex, male and female. So you're going to do some experiment, and I mean, when I say experiment, what I'm talking about, the problem that you're going to solve, you need to know how many female uh, students have autism and how many don't, and the same thing goes with the male. So since there are like I think there is a close to 1,000 data points here. Let me just make this one. So it's how it is the way that you should do it. You should be able to use Excel and do it. See that? How many do we have? How many? Data points are 956. And you can see that on the middle column here, male and female. On this one, yes and no. Mostly you see no, but there are yeses too. This is yes. You can see that. Yes here. So we want to sort these. In order to sort these, so where is my sorting? It is here. I'm going to open this up again. Here is the sort. You're going to click on this one. First of all, what I'm going to do, I'm going to highlight this column. And then I'm going to sort, go to the custom sort, not to A to Z custom sort. And then instead of, don't pick the expand the selection. And then when you get here, you can, when you click on that, it says sex, male and female, autism spectrum disorder, yes or no. So I'm going to do with the autism. I'm going to say okay. And when I say okay, I got to look at this one. Now, I'm hoping that all these have been sorted. Let's see. No, 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 no. If you go all the way down, it should be yes, 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 yes. There we are. See that? It's been sorted. But this is in terms of yes and no. But now I got to sort the middle part. So again, you do the same thing. The middle part, the middle column, and you go here, custom sort, and this time you go for that and say okay. And hopefully everything is not sorted. Sorted. Let's do it one more time in case. I don't understand why this becomes okay. Everything is male, female. You see that? Now everything from here all the way up there, you have female, and these are yeses, are sorted. You have 4 of them as autism. The rest of them are no. So the way you count these, do not just count by the cell. Just click here, use the count, the command count here. You use count, and then in this case, this is easy for this one. You enter, so, oops, you have 3 of them. Oh, you got to go in terms of numbers. So anyhow, you have 4 of them here. When you go to the down here for male is, you have these numbers. What is it? 3, 6, 9, 10, 11. So you sort them. In terms of the autism, yes, for male, you have the number, and you can count these numbers too. Use the command count. Are we okay with this? How to sort things like that? Do you have any questions? Yes, no? You don't have questions, or you do have questions? Kelly? No, thank you. Thank you, Ryan. Because someone said no. Okay, so we are done with this, right? No Excel questions, so I can go back to my, how many 10? Oh, still have 10 minutes. I can still lecture. But if you don't have any questions, I'm going to go back there, unless you have Excel questions. Do you have any Excel questions? No. Good. You guys are doing great. Wow. I'm impressed. Okay, so we are going to go back to stop this now, go back to the lecture mode. Lecture mode, high quality, not sharing. Okay, we are back. This is, finished page 1. I gotta find my page. Okay. All right. So what we have here, this is back to the lecture part. This is chapter 23. So we're talking about two proportions. Here is the definitions. We're going to look at. See that originally for one sample, for one proportion, population proportion, it was just this part. Now you have extra terms. You have the difference. It's the same as what we had for two means. It's exactly, you can see the similarity. It's exactly the same. Okay? All right. This is the formula for the population proportions, two of them. I want to show you what we had for um, two means. We had two means, and if you recall that it was x bar 1 minus x bar 2, plus and minus, and then we had t star, and then we had s1 squared over n1 plus s2 squared over n2. Difference in the means, now difference in the proportions. You have, instead of having t star, you have z star here. And again, this is the standard deviation. And you can see that this is but the two standard deviations. One is due to the two samples with the two sizes. And remember, we said this is standard deviation. Again, the same thing, standard deviation for two samples with the two sizes. The same thing. The concept is a little bit different, but it's the formula is a little bit different. Concept is the same, but the formula is a little bit different. So the criteria for this is for the large sample confidence interval for the difference of a population we need to make sure that N1P1 greater than N, and that's greater than N2. So that means, again, this is the failures for each group. This is the successes, N1P1 for group 1 must be greater than 10. Failure for group 1 must be greater than 10. Successes for group 2 must be greater than 10, greater than or equal. And failure for group 2 must be greater than or equal to 10. So those are the conditions. In other words, the number of successes and failures in both samples needs to be at least 10. That is the condition. And again, for P1, if you want to calculate P1 hat, you recall that we had number of successes plus the sample size of group 1. I'm going to write group 1, sample 1, sample size of group 1. And P2 hat, number of successes of group 2 divided by sample size of group 2. Okay. And remember, the failures, and regardless of the group, or successes regardless of the group, it must be greater than or equal to 10. Okay. Okay. How much time do we have? Well, we have 3 minutes, almost 4 minutes, to reach 4 minutes. If I start this, I'm gonna stop it in a minute. Let's just stop it right now. We'll stop it right now, and we'll continue this on Wednesday. Seems to me I'm gonna finish this on Wednesday, probably. I have 4 pages. Who knows? I might put the problems on Canvas for, you know, extra problems that I'm gonna do. I'm planning to do. I'll put them on Canvas hopefully before next class. That would be Wednesday. Because if I finish this on Wednesday, I would like to do some problems. All right? Okay, folks. Have a good afternoon. I'll see you guys on Wednesday. Come to my office hours if you have questions. Thank you. Have a good afternoon.